morning to all.
Good morning.
So we have all gathered here for a case study discussion on smart waste monitoring system. So the urban countries are producing more waste, and inefficient collection of these waste would lead to unwanted health hazards, pollution, etc. So the traditional system of waste management, they lack in real-time monitoring of the waste. So what they do, unnecessary fuel collection, waste collection without the proper monitoring leads to time wastage, and there will not be efficient waste collection. So here we have to make use of IoT and various embedded platforms to design an efficient waste management system. So I'll give you 5 to 10 minutes, discuss among yourself, and with the help of the embedded platform, design an efficient waste management system. Hope you have completed the discussion. You can start providing the solution.
So I'm giving the intro part. So I'm saying about the urban cities. We have in many places we can see the garbage wastes. It will overflow. If it is overflow means we have some bad smell. It causes pollution and it causes sometimes disease also. So to avoiding this, we need to find solution for this. So for example, if daily the garbage collectors are came means if the fuels also waste and their time also waste, because daily the garbage is not full. But if for this to avoiding for time fuel unnecessary times, so we using the IoT devices like Raspberry Pi. So in this model, it will give the notification alerts if the garbage is full means or going to be full means it will give the notification alert to the garbage collector teams. So then they will come and collect the wastage. So in this method they save their times, they save their fuels, and it does not cause any pollutions for any peoples. So we using this method.
So just like Joshika said, we will be needing a waste management system. So for an efficient waste management system, we'll be using few components, and when we put all these components together, we'll get an efficient method. So first off, to understand it better, like the objectives are first we'll be needing the system architecture. So coming to the system architecture, there are 7 layers, but then for us, the first 4 layers will be more efficient. The first one is sensing layer. So we'll be using ultrasonic sensors because we will be notified how much amount of the waste have been collected. Gas sensors, which will detect unwanted gases, and then we'll be using temperature sensors, which will detect any if fires or anything happens, it will be detected. Next is processing layer. So in this processing layer, we'll be using Raspberry Pi, which is very efficient because it's small in size, it's very cost effective, and it does a lot of processing works. It makes makes the works easy. So we'll be using that, and in the communication system, we'll be using Wi-Fi modules, GSM modules, so that the processed data will be sent to the cloud. So the next is application layer. In the application layer, we'll be having the cloud database. So the processed data will be sent to the cloud, and that will be displayed in the dashboards, like in a website or in an app. So that's the application layer. And the next one will be the hardware components. So like I said, we'll be using ultrasonic sensors, Raspberry Pi module, GSM module, Wi-Fi. So we'll be using all these kind of things along with the power supply and the connecting wires. So when we put everything together and when we use softwares like Python along with the Python libraries, I think we will be making a good efficient method for the smart waste management system.
So that is the main advantages
collecting the garbage waste using the embedded system. Real-time monitoring. We are putting the waste in the garbage bin. Instead of that, either it is filled or not, it sends the alert message when it is the garbage bin is filled or not. Optimize that the garbage bin is either filled, it automatically sends and reduces the height of the waste, and it recycle the bin every minute. And that is the main advantages. Instead of you correcting the old method, it is one of the best method. We can save the energy efficiency and power reductions, and manual power decreases.
From the intro part, as Joshika says, what reality faces. And in smart waste management system, I'll tell some challenges. First thing, there might be doesn't get accurate values due to noise, dust, etc. And second thing, the power supply is the main problem, because power supply need continuous electricity or the battery maintenance. And thirdly, internet may be unstable in local areas, some areas. So it need a proper thing. Because of this thing, the data may be delayed to update. And fourthly, the initial cost might be high, the need hardware installation, and also these are the challenges need to be solved to get an effective solution.
So how do you overcome these parameters, like how to save the power, internet facilities, etc.?
In future enhancement, we have to focus on the challenges we are faced before. The first one is accuracy is very low. So for the accuracy is low, we have to integrate AI models, machine learnings. For that, already we are using Raspberry Pi. Even though that is enough for small ML models, that is not enough for accurately. So we have to integrate Google AI accelerators, that is run heavy AI models. And next one is poor internet connection. In all before systems, we are using GSM models. So we have to interconnect LoRa models. If LoRa is connected, there is no internet is required. And next one is low power consumption. For that, we have to integrate solar panels. So it will sustain the self-sustainable system and eco-friendly.
Good. So thus, as per our discussion, with the help of reliable embedded platform, that is Raspberry Pi code, and integrating along with the AI and machine learning algorithm, we can design an efficient, smart waste monitoring system. Thank you all.
Thank you.